Hi, my name is Dr. Ian Moore. Today I'm going to talk to you about the Johnson & Johnson vaccine that has recently received emergency use authorization from the FDA. In a previous video, I talked about mRNA vaccine technology and how those vaccines work. And so ahead of the mass rollout, even though this vaccine is now starting to come out, I wanted to make sure that I informed people about how the Johnson & Johnson vaccine worked. The two technologies are different. The Moderna and Pfizer vaccines are mRNA, and the Johnson & Johnson vaccine is a vector vaccine. And so, as I describe the difference between the two, I'm going to point out some important details. But before I do that, I want to speak to you, if you're watching this video, and let you know a few things about me and my passion to inform people about these vaccine platforms and the process of getting vaccinated. So one thing that I did not mention in the previous video is that my background is actually influenza research. So as a PhD student, I spent a few years in a flu lab looking at the pathogenesis and the immunology of different influenza viruses in different animal models. And in that process, I learned a lot about vaccine development, how vaccines work, and I've actually engaged a lot of discussion with people about the importance of influenza vaccinations, dispelling some of the myths that were associated with it. And so I want to make sure that I do the same thing when it comes to coronavirus. There have been many people who have died from this virus over the past year. As I mentioned in a previous video, back in early 2020, people were often saying that they didn't know anybody who was infected. Fast forward a year later, you know a lot of people who were infected, and you possibly and more than likely know somebody who's died of this virus. So with that being said, I think it's very important that everybody understand what these vaccines mean for us, that they are safe and they are reliable, and that you should get one. And I'm not promoting anyone. Even though I worked in the development process for the Moderna vaccine, I'm telling you, you should get Moderna, Pfizer, or now Johnson & Johnson. Anyone that's available to you, you should take it. The other point I want to make is that I have a real concern that in some of the rural communities and some of the minority communities, that information is not making its way there in the same degree that it's making it to different populations. With that being said, this is exactly the reason why I'm making these videos. I'm making these videos so hopefully they can get out to the people who may not have a broad internet infrastructure, or people who may not follow some of the larger cable news networks who often do talks and give information. So what I want to do is make sure that everybody has a level playing field when it comes to vaccine rollout, but then to let people know that the vaccine is made for you. Everybody was included in these clinical trials, and then the vaccines are safe. The bottom line is that you look at numbers from Pfizer, Moderna, 94-95% efficacy. Then you look at Johnson & Johnson. In the United States, it has 72% efficacy. But those two numbers are different because the Pfizer and Moderna vaccines were tested early in the process when there weren't as many variants circulating. Fast forward, Johnson & Johnson is tested in clinical trials, and it's tested in the face of 3 different variants: the Brazil, the UK, and then the South Africa strain. So it's really not looking at the two vaccines in the same light if they're being tested under different circumstances and different conditions. So that 72% is still very effective. And just as a point of reference, some of our most effective vaccines, flu vaccines from the past, have only been 50-60% effective. So 72 is still very good. But the numbers that you should focus on, especially with the Johnson & Johnson vaccine, are 85%, which is protection from severe disease and hospitalization, and 100% protection against death. None of the people who were in that trial died from coronavirus. So that's a very good number. So there is true protection, even in the face of some of these other variants that are circulating. So the take-home point is get a vaccine, get some protection, because some protection is better than no protection. If you don't have any protection, you are a clean slate, and the virus can have its way with you in a sense. So with that being said, I'm going to go ahead and introduce the platform, the vector vaccine platform. So as I've shown you before, this is the coronavirus model that I made. These projections off the surface, these are the spike proteins. We've heard the word spike protein in many different capacities on TV, maybe on the radio, but these spike proteins are how the virus gets into your cell. To illustrate that, these spike proteins are the key. They're the key that unlocks the door that's in your cell. I have a lung cell. So a nice, healthy, happy lung cell. This blue is the nucleus. The light blue part is a cytoplasm. So what happens is, in a very normal situation, your lung cells, you have a virus particle floating in the air, and it makes its way into your nose, down your trachea, and then to your lungs. And once these keys that are projecting off make contact with the door, the lock on top of your cell, it can go into your cell. Once it goes into your cell, you have virus replicating, and you have more virus in your cell. So if you look, these little virus particles have new spike proteins or new keys. Once they leave the cell, they go off and they find a new lung cell to infect. And so the process keeps going until you have more and more virus in your lung. So let's talk about how the Johnson & Johnson vaccine works to protect you from this process. So we come back to our virus particle. We talked about these spike proteins. These are the keys. So now what we're going to do, we're going to take just one of these keys and talk about just the key. So this key is the spike. And so what scientists have done is they're able to take the genetic sequence that makes this spike protein. So it's not the virus. The Johnson & Johnson vaccine does not have coronavirus in it. It just has the spike protein. And I'm going to talk about how another type of delivery system that they use that's different from the mRNA vaccine. This is the sequence. This is the instruction, the genetic instruction to make just the spike protein. This is then introduced to the body, but how do they get this in the body? This is where the vaccine from Johnson & Johnson differs from the mRNA. And I would suggest, if you haven't watched my first video talking about mRNA vaccines, you should, because it leads into this talk that you're hearing right now. This is it's one of the common cold viruses. It's called an adenovirus. In particular, the one they use in the Johnson & Johnson vaccine is called adenovirus 26. So typically, adenoviruses cause common colds, but in this case, this virus for the Johnson & Johnson vaccine has been modified. It's modified where it won't cause you any disease and it won't replicate in your cells. It is strictly just a vehicle. It's going to transport this recipe or this instruction. It's going to take it into your body and into your cells where it drops it off so that you can have the process that we're going to talk about. So now, let's pretend that this virus particle, this is the adenovirus particle, it's been modified, it won't make you sick, it won't replicate. It's carrying the genetic sequence or the recipe for the spike protein. So what you notice here is that it reminds me of a Trojan horse. In order for this sequence to get into the cell, it needs to have something to carry it. And that's where the adenovirus comes in. You have your injection. You get a shot in the shoulder. This is going to take this virus particle, and a lot of them actually, a lot of virus particles that carry the recipe for the spike protein. So inside of your muscle cells, there's a structure called a ribosome. Think about a ribosome as an oven. This, as I mentioned, is a recipe. So after this virus goes into your cell, it goes to your nucleus and it drops off this DNA sequence for the spike protein. This spike protein sequence is then changed to mRNA. That's a very familiar term that we keep hearing. So if you think about it, my pause right there. If you think about it, the biggest difference between the mRNA vaccines that I described in my first video and this virus, the Johnson & Johnson vaccine, the biggest difference is that The Johnson & Johnson vaccine uses an adenovirus to take the DNA sequence in, and then it's like a step before the mRNA. It's an extra step ahead of the mRNA process that we described for the mRNA vaccines from Pfizer and Moderna. So once this gets into your cell, this genetic sequence is dropped off. It's dropped off in your nucleus, and then it's changed to mRNA. Once that mRNA is floating around in your cytoplasm, it goes to your ribosome, as we talked about. It goes to the oven. Once it goes to the oven, then just like any recipe you have, you mix up batter, you put it in a pan, you put it in the oven. The oven cooks the recipe. And on the other side, when you open up the oven, you have your new spike protein. Let's look at this muscle cell. This green structure here is the ribosome. The genetic sequence, the mRNA sequence, went into this oven, and out came on the other side these little baby spike proteins. If you see, these spike proteins are now on the surface of your muscle cell. Once they're on the surface of your muscle cell, they're picked up by immune cells called macrophages. Those macrophages pick these little spike proteins up, and they take them off to the lymph node. In the lymph node, they educate the lymph node, and they educate the lymphocytes, the T cells and the B cells, about this spike protein. And they tell them, they say, hey, if you see anybody come around with this spike protein on their surface, you do your best to get rid of them, you attack them, because they're not supposed to be here. And so that's the role of your B cells and T cells, in particular B cells, because they're going to generate antibodies. And if you have antibodies that are generated to this spike protein, let me show you what happens when your body's exposed to the real virus. You've been vaccinated with the Johnson & Johnson, this one shot. And so now this is 14 to 28 days later. You have a really nice, strong immune response, and you have antibodies. So what happens is your body, once it's exposed to this guy, the real virus, which still has a spike protein. So now you remember, your body has a heads up. Your body knows that it's going to be looking out for these keys that are trying to get into your cell. Say you have another weapon now. You have antibodies. Silver beads are your antibodies. So they are released when your body comes into contact with these guys. So this virus circulates, and look what happens when you have antibodies in the presence of a virus. So if you notice, these antibodies coat the entire virus particle. Once it's coated, it's really, really difficult for the key to make contact with the lock. They block, they get in the way. You see that? They get in the way. So when they get in the way, that protects you from the virus, and protects the virus from being able to get into your cells. If it can't get into your cells, it can't replicate. And if it can't replicate, it just hangs out with all these flags on it, and those flags result in this virus particle being taken away. It's taken away by a macrophage or some other cell that's going to gobble it up and remove it. This Johnson & Johnson vaccine used an adenovirus as a vector, as a vehicle, as a car, to transport the genetic sequence of the spike protein into the cell and into your body. Once that happens, you generate, and it's the same process as Moderna and Pfizer. You generate an immune response, and then you have antibodies to the spike proteins, which are the keys. Once those keys are seen on a virus particle, you come into contact with it. Those B cells release their antibodies, they coat and they block, and so the virus can't infect your cells. Johnson & Johnson vaccine is going to have a really, really special purpose for those people who live in areas where, for example, it's not a lot of refrigeration, or maybe you don't have the ultra cold storage that's needed for the Pfizer and Moderna. In addition to that, it's one shot. So just like Pfizer and Moderna, the Johnson & Johnson vaccine is very safe. These three vaccines that I'm talking about have been scrutinized way more than probably any vaccine in the history of vaccinology, partly because they were front and center. We've never had this technology and been in the middle of a pandemic and have the ability for people to watch the process real time, constantly checking the news, constantly watching the TV. So you should feel extremely secure with getting this vaccine. It's going to protect you. It's going to help you stay safe. It's going to help your family. But you have to still stay masked, especially after you get vaccinated. Some people feel that they can take their mask off the minute they get vaccinated. That's not the case. It's still a 2-week, 3-week period afterwards in which your body is starting to generate an immune response. So stay masked, get your vaccine, get any vaccine you can get, but I wanted this video to describe how the Johnson & Johnson, the vector vaccines work. They're a different technology than the mRNA vaccines, Pfizer and Moderna, but still very effective, still very safe. If you do have questions or comments, please leave comments on the YouTube page. Please like it if you do, because I do appreciate that, because I like to get the feedback and know whether or not you appreciate the information. But even if you have questions, please post me a question. I don't mind responding. I will absolutely get to you and respond. So with that being said, this video is a bit shorter than the previous video, but I'll say this. If you don't have, the previous video is 24 minutes. If you don't have 24, if you don't have 30 minutes to sit and listen to something that could potentially save your life, then you don't have any time. And so this is probably going to be one of the more important videos you watch, because I want you to understand what's happening to you when you go get vaccinated. So I want everybody to trust it. I saw the process from the very beginning all the way to the end for the mRNA vaccines, in particular for the Moderna vaccine. And these vaccines are no different. So have confidence in the vaccine, get your vaccine. Don't let yourself sit out and be completely open to infection. You have options now. You have 3 different options to protect yourself. So there is no need for you to have unnecessary illness, and definitely not put yourself in a situation where you or someone that you love dies. Take care of yourself. God bless. Please submit your questions. Take care.